Example 2 for tangent functions. We have fx equals to minus 1 plus tangent 2x. To sketch the graph of this function, we will begin with the phase shift so that we know the initial point, where is it, where we have 2x equals to 0. So it gives us the result x equals to 0, and the cycle will begin at x equals to 0. Next, we would like to find out the periods, where we have pi divided by modulus m. The m here is corresponding to the coefficients of x. So as a result, I have pi over 2 for the period, where one cycle of the tangent graph that we have later is completed in pi over 2. Follow, we would like to find out the sub-interval width for the table later, where we use period divided by 4. And as a result, we will have pi over 2 divided by 4. So we have the answer equals to pi over 8 as the common difference in the table later. But before we go on with the construction of the table, so in here, we need to find out what is the corresponding vertical asymptote for the one cycle case first, where for the vertical asymptote, we're going to calculate based on using the terms inside the bracket here, 2x equals to pi over 2. And as a result, we find out that we have x equals to pi over 4. And this is actually the asymptote that we will see later in our table for the one cycle case. And if let's say I need to have more vertical asymptote as a reference for graph sketching, what I will do is that I will have this value here plus minus with the value, the multiple of the value of pi over 2, which is the period's value, according to the notes that we have just now, where we have pi over 4 plus minus n times of the periods. So for some examples, if let's say I have pi over 4 plus with the period value pi over 2, it will give me 3 pi over 4. If I minus, I get negative pi over 4. If I go on further with the calculation of plus pi over 2 to the right, I will have more vertical asymptotes. If I minus pi over 2 towards the left, I will have more vertical asymptote on the other side. Next, now we go on with the constructions of the table. Okay, based on the info that we have just now for the phase shift, periods, sub-interval width, as well as the vertical asymptote, now we can construct the tables based on this information for one cycle graph, where I have my tables begin with the x value of 0 from the phase shift, and then the next value we will add on, with the sub-interval value, the sub-interval width, and this will give me the answer pi over 8. Add another pi over 8, I have pi over 4, 3 pi over 8, and at last I have pi over 2. Then before we go on further on the value of fx here, I need to warn you and remind you again. Let us identify where is the vertical asymptote here first, just to avoid unnecessary math error or error that you obtain during calculation using your calculator, where we find out that the vertical asymptote in this table here is located at pi over 4, which at these positions here. So let us quickly jot down first that this is the vertical asymptote location. Then next, only we calculate the corresponding positions accordingly. So we have minus 1, 0, follow, minus 2, minus 1. And later, when the time we go for graph again, I would like to let you know that the two values here, the two values that our vertical asymptote in between is the value for the guideline for us to know that by the time we approach the asymptote, the graph is approaching upwards or downwards to positive or negative infinities. Okay, next. So with the reference of the table, let us insert all the x value here accordingly to the x-axis. So I suppose I have the result as follow. Next, what I will do is that I go on with the y-axis, insert in the corresponding y value that I need to use for reference. In this case here is minus 1, minus 2, minus 1, and 0. So therefore, these are the value that I want to use for reference. And now we start the plotting. We start with the first pair, 0, minus 1, pi over 8, 0, the vertical asymptote, 3 pi over 8 minus 2, and lastly pi over 2n minus 1. And now we can start to go on with the graph sketching. And in this case here, we can see that the graph will look something like this, where the point here at pi over 8 is guiding us to approach to positive infinity. As you can see, these two consecutive points here is coming in the way of increasing. The other one, it seems to be in these directions for the graph sketching approach to infinity. And once the graph is done, again, we erase the unnecessary plotting, the red plotting we need to erase. And also, we erase the guideline point that for us to know whether approach to positive or negative infinity when the time we approach to the asymptote. So this is the foundations graph that we have for one cycle. So as you can see, the -2 is cleaned off because it is not an important reference point for graph sketching later. And also this part here, the value 3 pi over 8, also we erase it. But the value of pi over 8 is still remain because this is x-intercept, is for information. Xy-intercept is important as a reference of graph sketching. That's why it's still maintained here. So this is how we get the graph for one cycle for these functions here. And next, if let's say I would like to have the case where the domain happens to be from infinity to infinity. So what we're going to do is that, again, we use the one cycle graph here as the foundations. Then next, what we do is that if let's say I happen to have my coordinate axis, the x-axis is as this white, then for the case of sketching all real numbers for the domain, the coverage should be the part that I highlighted in green here. And next, what we're going to do is that let us extend the marking on the x-axis. And in this case here, after the value of pi over 2, the next value that I should have here, it will be 3 pi over 4, where we have it plus pi over 2. As you can see from the marking here, from pi over 4 to pi over 2, I need to add on with pi over 4. So we add on pi over 4, we add on pi over 4. The other side, we minus pi over 4, we minus pi over 4. And please make sure you don't get disturbed by this x-intercept here for the marking. If you felt that this part here will happens to influence you to give the wrong result, maybe we can hide it first, we can erase it first. Okay, so this is the marking that we have from x-axis. Now we go on with the graph sketching, and by right, beside we have the vertical asymptote at pi over 4. We find out that we're going to have vertical asymptote at the location of 3 pi over 4, where if it happens to be this foundation vertical asymptote, we plus with the period value, which in this case here is pi over 2. So I have 3 pi over 4 as another vertical asymptote. On the left hand side, the vertical asymptote will be at negative pi over 4 because minus the period pi over 2. So as a result, if we extend the graph, this is how the graph looks like. And this is the case how we get the graph for all real number. And what if, let's say, another common case that we will see is that they want domain from 0 to 2 pi, which is equivalent to 0 to 360 degrees. So how we're going to get the answer here is that, again, we use our one cycle graph as a foundations here. So the one cycle graph we have is that from x equal to 0 until pi over 2. And now, if we want to go on to sketch until 2 pi, we need to identify how far it will go, what is the coverage of it. So let us extend the marking on the scale on the x-axis. So after pi over 2, the next marking I will have is that 3 pi over 4, and be aware, the marking is in this case here is not based on the sub-interval just now, but based on the graph here, the difference from pi over 4 and pi over 2, which is from pi over 2 to the asymptote, the difference here. Then next, pi, 5 pi over 4, 3 pi over 2, 7 pi over 4, and at last we can reach exactly 2 pi. So therefore the coverage I need here for the domain is what is highlighted in green here. And with this is being identified, now we can extend our graph accordingly, where this is the result that I should have if I extend accordingly. And once again, you check the asymptote from one to another, you find out that is equivalent to plus with pi over 2, which is the period value. And this is how we get the answer for the case of example 2 in tangent functions.